Hello and welcome to this lesson about multi-step equations. The learning target for this video is being able to solve linear equations and determine the number of solutions. So when we're talking about multi-step linear equations, we're talking about equations that are very complex and they have maybe variables on both sides of the equation. So for example, let's say we had 7 minus 8x is equal to 4x minus 17. The thing is, we have to do a lot of manipulating of the equation while maintaining its equality in order to solve it. And so when we're solving equations like this, what we want to do is isolate the variable and balance things out. So those are my two key words for solving equations. We want to isolate and balance. We also want to get the variable by itself, and so that's really what isolating is referring to. So what I like to do is to keep my variable positive. So when it comes to solving a problem like this, I'm going to add 8x to both sides. Because by adding 8x, I'll have positive 12x on the right-hand side. And so at the same time, what I'm going to do now is add 17. Because what I'm doing is I'm moving all the variables to this side. And so I want to move my numbers over to this side over here. So that's where the numbers are going to go. So I'll add 17 there and add 17 there. And as a result, I get 24 is equal to 12x. And now I divide by 12, and I have x equals 2. So there's one example. Let's do a second example. Let's say we have 9x minus 5 is equal to 1/4 times the quantity 16x plus 60. Now the game plan remains the same. Isolate and balance. But what I have to do is I have to do some distribution. Sometimes I can avoid having to distribute, but because I have two things over here, I can't, 9x minus 5, I can't really, I mean I could, but I don't think it's going to help me out that much. So what I'm just going to do is kind of bite the bullet, if you will, and I'm going to distribute my 1/4 here. I'm also distributing it because I know these are both divisible by 4, and when I multiply by 1/4, that's really what I'm doing, so I'm dividing by 4. So I have 9x minus 5 is equal to 4x plus 15. Subtract 4x from both sides now, because again I want to isolate everything, move it to one side. And so the variables are going this way, the numbers have to go that way. I will add 5 to both sides. And here's where we got to be careful. Sometimes you're going to see -5 and you're going to see 15 and your brain's going to think 10. But that's why it's important to show your steps and take your time, so that way you realize it's supposed to be 20 on this side. And then here you'll get 5x, divide by 5, divide by 5, x equals 4. So that's really what this is taking your time, showing your work, and being thorough to make sure you don't make small mistakes like that. Let's do one more example. Let's say we have 3 minus 4x is equal to 5 times the quantity x minus 3. Okay, so again, I need to do distribution. Here, I definitely won't get anything if I try dividing by the 5. So I will get 3 minus 4x is equal to 5x minus 15. Be careful with the distribution, especially if there's a negative sign on this one. There isn't here, but just be careful. That's where students make mistakes. Again, I like to keep my variables positive, so I'm going to add, oops, not 5x, I'm going to add 4x to both sides. 4x, 4x. And so since the variables are going this way, the numbers got to go that way, and I will add 15. Add 15. So I have 18 is equal to 9x. Divide by 9, divide by 9. X equals 2. So before I move on to the next point, I just want to wrap some things up here. A lot of algebra is a variation of x plus 1 equals 2. And so up to this point, if you've been watching my videos or been in my class, you've seen that like we start off real simple, one-step equations. And then we just add steps to it to make it maybe a little more complicated. We make the numbers larger, we make them decimals, we make them fractions, but all it is it's still the same problem. It just has one extra step. That's all we're doing, is constantly adding more and more work to what it is we need to do. So it might be something like that, plus 1. So that's linear equations. If you understand that, it's just x plus 1 with an extra step, it's very manageable. And then it's just about bookkeeping. Are you being diligent with your work? Are you showing your work? Are you taking your time and avoiding small mistakes? Now, let's talk about solutions. When it comes to equations, we have 3 kinds of solutions. You have normal, which is x equals a number. It could be any number it wants to be. We have no solution. And we have all real numbers. Now, these happen here when there are no variables. So what's happened is that you've canceled out your variables. And so you end up getting 2 numbers. So you'll have a equals b. A equals b. Now, all real numbers is the solution when a equals b is a true statement. So you're crunching a lot of numbers, you get 3 equals 3, or you get 0 equals 0. That means it's all real numbers. No solution is when you have a equals b, and that is false. You have 1 equals 5, negative 3 equals 0. If that's the case, then the answer is no solution. So let's walk through a couple of examples. All right, let's say we have 3x plus 1 is equal to 5x plus 4 minus 2x. Now what we need to do is combine some like terms here. So we'll have 3x plus 1, and then 5x minus 2x is 3x plus 4. Next, subtract 3x, subtract 3x. And that's all I'm going to do here, because it's going to make my point, because the 3x is completely canceled out, and we're left with 1 equals 4. That is a false statement. 1 doesn't equal 4. So our answer is no solution. Let's do another one. Let's say we had 2x plus 8 is equal to 4 times the quantity x plus 2 minus 2x. So here we have a lot of numbers we have to crunch. So we'll leave 2x plus 8 is equal to, now do my distribution, 4x plus 8 minus 2x. Combine some like terms. 2x plus 8 equals 2x plus 8. And so what I end up getting is, these are like terms, so, not like terms, I'm going to subtract 2x from both sides, and I end up getting rid of those, and I have 8 equals 8. That's a true statement. So what that means is that my answer is all real numbers. And you can see that at this step right here. No matter what I put in there for x, it's going to be the same, because I have to multiply it by 2 and add 8. Likewise, you could probably see the same thing here. Regardless of what I put into x, it's not going to be the same. I'm multiplying that number by 3, and then on one side I'm adding 1 to it, and on the other side I'm adding 4. It's just not going to work. So, when we're doing multi-step equations, it is possible you cancel out the variables. And when you do that, that means you're either going to get no solution or you're going to get all real numbers. And let's just talk about that a little bit more. So let's use some vocab to describe what's going on here and how all of this works. In order for us to have a situation where we have no solution or all real numbers, the coefficients must match up. Coefficients must match up. And so the coefficients are these numbers, the ones next to x. I'm going to scroll up a little bit. Now, if we want all real numbers to be our solution, the vocab way of describing that is that the constants must be the same. Constants must be the same. And so the constant is not a variable, it's just a solid number. And so these must be the same. Now, again, coefficients must match up for either of these to be the case. Now, if we want no solution, the constants must be different. And there we go. That's everything about multi-step linear equations. It's all about isolating and balancing, getting all the variables on one side, the numbers on the other side. When you do that, you may accidentally cancel out the variables because they might have the same coefficients. If that's the case, you're either going to get all real numbers or you're going to get no solution. So good luck with your homework and practice, and let me know if you have any other questions.